Welcome back to the channel Understanding Concepts of Physics. Today we are discussing one of the doubts posted by one of the physics enthusiasts, a student of the subject, and he has questioned me on the YouTube itself, and I am just trying to solve that question. So the question is that find the minimum colatitude which can be directly receive a signal from a geostationary satellite. So there are no numbers over here, but still there are so many numbers over here. Yes, you heard me right. There are no numbers here, but there are so many numbers. First of all, it is a geostationary satellite. Geo stands for geographically stationary satellite. So it appears stationary at one point, watching from one particular point on the Earth. So this geostationary satellite is basically like moving with respect to the Earth. There is no motion of this object with respect to the Earth. It appears to be stationary when it is moving, and the speciality is that Earth rotates rotates once in 24 hours. This also rotates once in 24 hours. So if you are watching it from one particular point on the Earth, this satellite appears to be stationary. That's why it is called as geostationary. Sometimes it is also called as geosynchronous satellite. Geosynchronous satellites, okay, and it is sometimes also called as communication satellites. So these are just names of the same thing, and they are asking what is the minimum colatitude which can directly receive a signal. So for directly receiving a signal, the path should be straight. If there is some obstacle in between, then definitely it is not going to receive it. So let's see. Now, geostationary satellite, there are certain specialities about this, is that the time period for the geostationary satellite is 24 hours. So whenever it is mentioned geostationary satellite, the time period is always 24 hours. Geosynchronous satellites, T is equal to 24 hours. Communication satellite, T is equal to 24 hours. Okay. Then we know that in the if you just go and study about gravitation, you will see that the time period of a satellite is given by the formula as 2 pi root of r plus h the whole cube upon gm. Now this is one of the formulas which we have in gravitation for the time period of a particular satellite, and if you put t is equal to 24 hours, g is equal to 6.673 10 raised to minus 11, t is equal to 24 hours. Of course you need to convert that into seconds. G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kg square, and mass to be equal to the mass of Earth, that is 6 into 10 raised to 24 kgs. And now if you put that value, and if you try to find out r plus h, then this r plus h comes out to be equal to, which we also write as small r, is equal to 42,000 kilometers. And height of a satellite, which is generally measured from the surface of the Earth, is equal to 36,000 kilometers. So this is what it is. I mean, if this is your surface of the Earth, this is your center of the Earth, this is your radius, and this is your height, then this entire thing comes out to be 42,000, and this h comes out to be 36,000. So this is what that previous calculation leads up to. So we'll just pick up those values and we'll start our calculation. So time period is 24 hours. The distance from the center of the Earth is 42,000, and from the surface of the Earth it is 36,000, because we have to subtract the 6,400. Now again, these are approximated values, not exact values. So like you will say, okay sir, if you subtract 42,000 and 6,400, this doesn't come out to be 36,000 exactly, but then these are approximated values. So just make sure that if you want to calculate, then you calculate it by this formula r cube upon gm, and this r cube you will come out to be as 42,000. Anyway, so today we are supposed to find out what is the minimum colatitude. Now what is this colatitude? Colatitude is the difference between the latitude angle and 90. So latitude angle is basically like, let's say if this is our Earth and this is our equator, the dotted orange line is our equator, and as you are on the equator, the latitude angle is 0. As you kept on moving upwards, then you will find out that the latitude angle actually increases, and it keeps on increasing, and when you are at the poles, basically you are at a latitude angle of 90 degrees. Same it goes for the lower hemisphere as well. So the latitude angle keeps on increasing, and at the south pole the latitude angle is maximum, that is 90. So if you are exactly on the equator, then your latitude angle would be 0. But like, let's say you travel to some countries which are in the northern hemisphere, but it's not so much at a height from the equator. Like you travel to Dubai, or maybe let's say you travel to even in India, also India, Pakistan, China, Russia, all this comes at this point. Siberia, Alaska comes in the northernmost part, and then you have the Arctic Ocean. And same way, if you go to Australia and New Zealand and then Antarctica, then you go to the lower side. So this angle is what is called as the latitude angle, which is generally denoted by phi. And 90 minus phi is what is called as the colatitude angle. Colatitude angle. So 90 minus phi, so this is your 90 degrees and this is your phi. So 90 minus phi is your theta. So theta is something what is called as the colatitude angle. So this is that angle we are supposed to find out. And by geometry you can also prove that if this is 90, this is phi, this is 90 minus theta, this is 90 minus phi. So you can also prove that this is also 90 minus theta. So this angle is also basically your colatitude angle. This angle is also called your colatitude angle. They both angles would remain same. So yes, now the radius of the earth. So from this point you have the center of the earth. This is the radius of the earth. So this is where you are able to receive the signal, and this is where the satellite is. So S is my satellite, and this is where I would find out. Now you will say, okay, why is not that this point not going to reach? Because the signals are going to reach straight, they are not going to bend. So it's like this. So it is going to hit the earth or hit the towers at this particular point. That's the reason why you will not be able to hear any receiving signals at this region. Same way you can do it for the bottom side as well, but one side is more than enough. Then from the center of the earth to the satellite, this distance is totally small r, which is I am mentioning that it is 42,000 kilometers. This I have taken into consideration that we know already. Now if you know these things, then the problem is simple. Like radius of the earth is, you know, that 6,400 kilometers. So if you see this triangle, this particular triangle, then in this case r is something you know, and this small r is something you know. This is a 90 degree angle, and this angle is phi. So if I use cos theta or cos phi is nothing but adjacent upon hypotenuse. Adjacent side is capital R, hypotenuse is small r, and we can do that. So cos phi is equal to adjacent upon hypotenuse, and adjacent is capital R and opposite is small r. So I get capital R by small r. I'll put the value. So 6,400 kilometers, this is 42,000 kilometers. Since both are in kilometers, we need not worry about the units because unit will get cancelled out. Once you cancel this out, you will get a number called as 0.1523. Okay, so this number you are going to get. Now you solve it by direct calculation, or you solve it by logarithmic, or you use a scientific calculator to find it out. Okay, so this is something I get. Then I'll take the cos on the other side. I'll get cos inverse of this 0.1523. Then finding out cos inverse is again a challenge for someone who is not using a calculator. If you are not supposed to use a calculator, then you will have to use a table of cos or a table of sine. So either one of them. That's one thing. And then let's say if you are allowed to use a calculator, then you just have to punch cos inverse of this number, and you will get as 81 degrees and 41 minutes. So this is a minute, this is a degree. Now this is phi, this is 81 degrees and 14 minutes, this is your phi, 81 degrees and 14 minutes. Okay, 14, is it 14? Yes. So 81 degrees and 14 minutes. Now, so this angle would be the 90 minus this 81.14. So 90 degrees minus 81 degrees and 14 minutes would be your answer. Now subtraction of this number, many people go wrong over here, so I am just doing it separately. 90 degrees, now you know that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. So 1 degree is 60 minutes and 1 minute is 60 seconds. However, this is not utilized at this point of time. I mean, at this juncture, in this numerical, we are not going to utilize this. We are going to only utilize 1 degree is equal to 60 minutes. Now if you see this 90 degrees I can always write as 89 degrees and 60 minutes. 60 minutes is again 1 degree, and 1 degree you can add it over here and you can always say it is a 90 degrees. But I have to subtract this from 81 degrees and 14 minutes. That's the reason I have taken 1 degree over here and converted that into 60 minutes. So 10 minus 4 is 6, and 5 minus 1 is 4, and here it is 9 minus 1 is 8, and this goes to 0. So I get 8 degrees and 46 minutes. Now why I'm doing this, because it's just not a number. It's not a number like 2.31 to 6.521. It is not just subtracting from two numbers where you borrow it from the previous number and make the number before less than 1 and then you add it up. Like I'm saying that, okay, suppose if you have a subtraction of like say 23 minus 15, okay, so then what you do is you borrow this 1 from here and it remains as 1, and this becomes 13, and 13 minus 5 is equal to 13 minus 5 is equal to 8, and then this goes to 0. So you do not do it that way, because there is this minutes and there is this degree. These are two different units of angle. That's the reason why I will have to work around like this. So finally I got an answer of 8 degree and 46 minutes. So this is where your 8 degrees and 46 minutes is. So I hope you have understood this question and the solution as well. In case you have not subscribed, subscribe the channel in case you have not done yet, and like, share and subscribe the channel. And any doubts you have, you can just post it in the comment section. I will try my level best to solve it as early as possible. Thank you so much. Have a nice day. Bye.